So, today's lecture will be on topsides. After that, I will talk about mooring system. Let us finish the topsides. So, I have told you about the layout considerations. Now, there are certain other considerations that you have to follow. Now, so this is your ship GA. Now, here actually there are some special considerations because this is an offshore platform. So, the segregation of the spaces I have told you, I have given you an idea. Now, the two major points that are to be remembered is separation of spaces vertically and horizontally. So, the main work of these types of structures are recovery of oil. So, recovery and processing of oil. So, the associated equipment should be geared to this recovery and processing of oil. So, actually all this if you want to understand, then this is actually related to your all major portion will be related to your chemical systems. Now, some of the terms that you will come across you will not be familiar with, because you are more familiar with a ship's GA. So, most of these systems that you will come across are related to chemical engineering, which is processing your crude oil or the cracking of crude oil. So, there are two distinct types of I told you operations. So, chemical, these are actually chemical processes. So, last class I told you whether your platform, what purpose this is going to serve, whether you are designing this for only drilling or only production or a combination of both. So, your topside facilities has to cater to this type of demand. So in most of the platforms nowadays you will find that they are capable both for drilling as well as simultaneous drilling and production. So, that means you have to arrange all your topside facilities according to the drilling and production modes. Now, the other point that is to be remembered is this oil is you are playing with oil. So, this is a hazardous sort of hazardous element, it's likely to catch fire. So, that means in your topside layout you have to separate spaces, topside spaces. First thing that you decide is separate fire risk. Fire risk categories of spaces. So, I will tell you what are these risks. So, you have to separate all these spaces because there are personnel on board and it should not catch fire. Now, the broad equipments that you finalize, so broad categories of equipment that you have to class according to and the spaces are going to be earmarked according to these broad categories of equipment. So, these are some of the new things that you will be learning while you are designing offshore platform. So, what are these broad categories? Now, broad categories, you segregate equipments into two broad categories. So, the first one is you write fuel source. And the other one you write as ignition source. So, now remember this, all your topside layouts are going to be inspected by your surveyors. So, that means you have to satisfy the surveyor requirements, and it may not be possible to segregate completely fuel source with ignition source, because of the constraint of space requirement. So, you have to strike a compromise between these two somewhere. Now, there is a trade off actually. So, you are playing, that is, the risk of fire is there. So, that is one of the most disastrous consequences. So, you have to strike a compromise between these two. So, all these factors are will come into your general management layout, that is your topside facilities. So, compromise between these two equipments, that is a fuel source and ignition source, as far as space allocation is concerned. You have to allocate spaces for these equipment. How you are going to allocate? And after allocating the spaces, what you are going to do? So, those are some of these fuel sources I will give you. Fuel source, you will find primary fuel source is your wellhead. That is from where the oil comes out. Then of course, you have a long list. Then you have manifolds. Manifolds are branches from where the pipings are taken. Then you have separators. So, I am not giving you all the equipment, but there is some of the list. So, oil treaters. So, basically you can see that these are all chemical engineering terms, but however, as a naval architect or ocean engineer, you have to know some of these. So, hydrocarbon pumps. Hydrocarbon is your oil. Now, all these are actually comes under the heading of fuel source, that is the sources of fuel or sources of oil. Then you have other heat exchangers, etc., long list. So, I do not have so much of time. So, you can take the notes. So, like this it goes on. Then you have last, you have chemical storage. And sample pots. And under this ignition source, that means these are sources which, that means it will catch fire. That means there should be what? Ignition source is a potential source of sparking or flash point. So, this first one is fired vessels. So, what is a fired vessel? Fired vessel. A fired vessel is something of your this boiler. The boiler is a fired vessel. It can be a oil fired boiler. Normally, of course, is a platform. So, you have a oil fired boiler. So, oil fired boiler is a potential source of fire. That means, you are having a fire over there, fire or a spark. Then you have combustion engines. So, these are mainly your engines for driving various pumps. So, combustion engines. So, this sometimes you may have for power, you may have gas turbines. So, that means you are having ignited gas in these turbines. So, those are potential fire hazard. So, you have number 3, you may have welding machines. So, like this you have static electricity. Static electricity is another potential source of fire. So, that means you are having sparking. Then you have cellular phones, flashlights, etc. So, that means if you go to a petrol pump, they will say that you switch off your cellular phone. So, similarly, here also you see cellular phones are not to be used, say flashlights. So, these are the equipments which causes spark or fire, and these are the fuel heads. That means, as such they are not burning, but they are, since they are having oil in it, they will catch fire easily. So, now these you have to separate these two categories of equipments. This is the first job. Now, the other job is the areas where you are going to locate them. So, area location. First you segregate the equipments, then you specify the areas where they are going to be located. Now, areas are, so one of the major area is your wellhead. So, again you find out source type, source whether you write is a fuel or it is a ignition source, fuel or what I had said ignition. So, like this you segregate your areas. So, wellhead is another one, then you have unfired processes. So, these are the area requirements. Then hydrocarbon storage. Then machinery, quarters, etc., living quarters. So, like this it will go on, then this is pipeline, then you have flares and vents. So, these you allocate the areas for these operations, specific area requirements. So, like this you have formulate your objective, but again you segregate on the basis of these two sources, that is fuel or ignition source. So, you remember this. Now, after this what you do is you find out what is called a wind diagram, or sometimes this is called a wind rose. So, this is another interesting study. You for that specific environment you construct a wind rose. Now, wind rose you will find it is a number of circles. Say you come across this type of circles. Now, wind rose actually gives you the percentage of the year wind is blowing at a particular direction. So, here you find that percentage of time. So, this is your 5% of time, this circle denotes 5%, next 10, then you have 15, say like this it goes on. So, 20% of the time you like this you construct a wind rose. Now, after that you give the directions. Say directions will be your north, east, south, west, and your platform orientation suppose is somewhere like this, or you can take this a wellhead orientation. Now, this direction will give you, that is less than 5% of the time in a year your wind is blowing in this direction, in the north direction. And if I draw a vector like this, then this will indicate, say this is more than 15%, say around 16 or 17% of the time the wind is blowing in the westward direction, and you have no wind. Say this is a typical wind rose for Gulf of Mexico, say calm, that is no wind is for 11% of the time. So, like this there will be a number of directions you will get, but directions please remember that this does not signify your intensity. The vectors only give you the percentage of time the wind is blowing at a particular direction. Now, after you have done this, you try to locate your spaces. Now, the first thing that you do, which spaces to be located towards the direction of wind. And which away from direction of wind. Why? So, this is a very important consideration, mind you. The first thing what you do is that you segregate the fuel source from the ignition source. That is your first job. Now, you find out which items you will be located towards the direction of the wind and which away. Because of the reason, that means suppose it catches fire, there is a flame, you have positioned it towards the direction of the wind, so the adjacent space will immediately catch fire. So, these are to be some of these I will tell you. So, this is called towards the direction of wind this thing is called upwind. And the other direction is called away from wind, this is called downwind. Or sometimes this is called in leeward side. So, when you happen to visit a offshore platform, you can see this this lecture, you will just get a glimpse of what is there in store if you visit a platform. So, downwind and leeward side. Now, upwind consideration, upwind spaces are these. That means, these spaces will face the wind. So, so these are living quarters. Now, next you have control towers or control buildings. Then you have helidecks. Air intakes for your sorry, this is air intake for your ventilation pumps, ventilation levers. So, those are air intakes. Then turbines, compressors, havoc in turbines, you have compressors, all these will be positioned upwind. Then number 7 is havoc, heating, ventilation and air conditioning equipment. Now, on the downwind side, so that is these are going to be protected from the wind. Downwind side you give vents. That is, the wind is blowing in this direction, the vent should be in the opposite direction. Do not place vent in this direction. So, these are some of the rules that are to be followed. Downwind side you have vents, storage tanks. Compressors, wellheads also will come here. Compressors, I think compressors here also we can give wellhead. and the other is boat landing. So that means if in case of evacuation of the platform has caught fire, people should not be exposed to very high velocity winds. So the boat landing you put on the downwind side. Then cranes. Sorry, this is 5. So these are some of the equipments to be located on the downwind side. Now after this, so these are some of the segregation of spaces that are to be remembered. Now after you have done the segregation of spaces, next what you are going to do? So this is your first job. Segregation of spaces, first you do for the ignition side, ignition and fuel equipments, then upwind, downwind. Now next, after you have done this, segregation of spaces completed, after this you do protection of the spaces. Now all these are geared for fire protection. Now space protection you do by 3 means. First one is you erect what is called a firewall. Number 2, I'll explain what is a firewall. Number 2, you erect a barrier wall. And the third one is called a blast wall. So in the event of an explosion, that means you have to erect a blast wall. So firewalls actually basically they provide what is called a heat shield. Now this is similar to your ship's GA. Whenever we doing the general arrangement drawing of any ship, you will come across in ships you will come across these 3 types of bulkheads. I don't know, in your ship design you will come across the ABC bulkheads. So these are similar to that. Instead of bulkheads, they are calling firewall, but their construction is different from these simple bulkheads. Construction is different. ABC bulkheads, so all these things if you want to know, you just look up what is called SOLAS fire regulations. Regulations for the prevention of the spread of fire, SOLAS or IMO regulations. So these are related to ships, but on a much more stringent scale you will find for space protection of platforms, offshore platforms. So in ships, if you come across these types of ABC bulkheads, in short I am telling you, A are the bulkheads which are made of steel. Okay. Now B is other type of bulkhead, may be steel or it may be of aluminum. C is made of this plywood partition, or marine plywood. So anyway, so those when you do your ship's GA, you will come across this, but similar this thing you will find here actually you come mostly steel. Now your firewall is actually providing a heat shield, but it should also allow personnel to escape. Now, actually the more detailed construction requirements you get in the API code. The code number is not given, this I think API RP26, that gives you all the you look API code, American Petroleum Institute API report 2G, this is 2G 1974, in detail about all these regulations. Now, personnel to escape. Now, barrier wall, their basic function is impede firewall is basically it will produce a heat shield for personnel to escape. Now, barrier wall impedes escaping gas. So, basically this is a gas tight compartment or escape or liquid leaks. So, this is a barrier wall. So, actually when you design a firewall is different from a barrier wall, okay. And blast is the last one is blast wall. Blast wall actually from the very term that is blast, you will find that it should contain overpressure. So, whenever you come across the word blast, that means there is a sudden buildup of pressure from gases. So, these are blast wall has to be designed in such a way that is to be specifically strong to contain overpressure. So, overpressure from explosion. So, after you have segregated the spaces, so you give protection to the spaces by either of firewall, barrier wall or blast wall. So, remember this in your topside GA plan. So, after this there are various equipments. Now, the other point that it is you should remember is that you have to plan. So, any general management drawing or topside layout that you are doing, first you segregate spaces, then you have to connect the spaces or access to all these spaces, access of personnel to spaces. This is also similar to your ship general management drawing. So, after you allocate the spaces, all the spaces have to be connected or serviced. So, remember that you should provide, suppose in your engine room or in your machinery room you have some machinery. Now, actually I have seen naval architects, they do not provide enough space for people to service the machinery. In a ship's main engine, you do not have enough space, that is you cannot walk around the engine or you cannot lift out the components. So, access plan, you have to draw what is called a approved access plan. This is very important, because after this, for the platform to become functional, you have to have a suitable access plan, and access plan is quite tricky. For first, why? Because your platform is quite a large structure. That means you have the deck, and suppose it is a gravity platform where you have to go down below into the water. So, the personnel will experience lot of dangers from high pressure and all this fire, high pressure and all these things will come. So, access plan for personnel is top priority to all these spaces. Now, how do you design an access plan? So, first of all, the personnel who is going to these particular spaces, he should feel protected, isn't it? You should not expose him to, first thing that you do in ships or offshore structure, you should not expose personnel to what is called bad weather, or suddenly he is thrown overboard. So, risk of personal safety is there. So, this is your primary consideration. So, personal safety, access plan, access to all these spaces that you have to provide. And remember one thing, as soon as you are providing an access plan, you are also providing a path for the spread of fire. So, that means the two, so you have to strike a compromise between all these things. So, nowadays what they do, your general management drawing, that is your topside facility, you do in 3D AutoCAD or 3D graphics. So, this is normally done in the shipyard in your design office, that you have to prepare your general management drawing in 3D. So, 3D graphics, I think most of you have done in SolidWorks, etc., or AutoCAD. So, you have to be quite proficient in that, and you have to 3D graphics, you have to do number of layers. So, that is called layering of the drawing. So, nowadays everything has been computerized. So, you have to be quite proficient in this. Now, here actually, so after you locate all the spaces, access plan, all this, the reason is that you have to do number of iterations to arrive at the final GA. To arrive at final stage, at final layout. So, because the items will continuously change, you know. So, people, and you have to interface with the other engineers. Say your main thing that will come as obstruction is piping. Your piping is very important in offshore platforms. First is location of all the equipments I have told you. Now, all these equipment, that is your wellhead, compressors, etc., and other machineries, they always have associated piping. They are not independent or standalone machines, you know. So, piping is very important. And how will you design this piping? So, there are this in your platforms, you have specialized piping engineers who do the piping layout. So, piping layout is this continuously clashes with your space layout. So, piping space layout always is associated with a piping layout plan. Plan with space layout. So, you can see that constructing a GA or drawing a GA is not a very easy task. First is segregation of spaces, then you draw the access plan, you connect all the spaces by access, and all the service, that is all these equipments and others, they have their associated piping. So, then again you have to do a piping layout. So, all these three will be either clashing with each other, or they have to harmonize, you know, they have to be linked. So, this thing is a major task, and piping, of course, I am not going into detail of this. Now, piping is very important. You have first is the internal piping, and then you have, for all these platforms, you have what is called cargo oil piping. Cargo oil, or sometimes these are called oil piping. So, these are actually different from your internal piping. So, some as naval architects, I think some of you should have some idea of this piping arrangement. So, I think after the mooring, if I have time, or I think your next offshore technology, I will talk about this piping. The mooring is finished. Anyway, so this access plan that I have talked about. So, this is to be remembered, and after you have designed, so personal safety. So, this is providing access to all your compartments, and now after your access, then you have to devise what is called escape routes. Now remember, that means your personnel, they are working in a platform which can either explode or can catch fire easily, if you have due to negligence or due to say blowout, etc., it can happen. So that means you have to have escape from all these spaces, escape routes devised from spaces. Now, escape route, when you design, the most important point that you should remember is that two escape. Now, this is also similar to ships. When you will be doing your ship's GA, you should never have two escape routes very close to each other. You should locate two escape routes at the farthest ends. Why? Sorry, farthest ends of deck or enclosed space. For the simple reason that if one of the spaces catch fire, then the personnel can immediately run to another space and he can save his life. So that means the two escape routes should be designed at the farthest ends of the enclosed space or deck, whatever it is. So here these are the major points that you remember. The other point, that is the quarters utility buildings. Of course, I have told you that you segregate and you erect a firewall, and normally the helipad is usually located on top of accommodation. Now, how are you going to design a helipad? So, a helipad is going to be designed, of course, with the weight of the helicopter, isn't it? And another consideration, to take copter load. Now, you have to provide sufficient area to provide what is called air cushion. You know what is air cushion? Suppose when your helicopter, you are trying to lift off, then the rotor actually gives a thrust. Now that thrust has to come from that helipad. Now, if you have not provided sufficient area, you will not get the sufficient thrust to give the lift to the helicopter. So, you provide sufficient area, and the strength, of course, will be due to the copter load. Now, copter load, actually there will be two types. One is you will find in the static case, and there is also dynamic load because of motions. Dynamic, because the dynamic is more prominent because it is coming from vessel motions and also copter motions. So, those have to be taken care of when you are designing a helipad. So, you will find helipad is quite strong, it is not a very flimsy what is called deck. So, these are the provisions to be countered if design escape route helicopter. The other thing that you come across is the load. There is a typical load intensities are given for your design. But these are given in the British units. So, load intensity in civil engineering they call it dead load. That means loads which are not moving. So, these are items you write float beams, then plates. Now, these are designed for 50 pounds per square inch. So, these are design load. Now, live loads are the moving loads. Live load, you write production equipment. Now, live loads for floor and beam design. Now, wherever you have live loads, so live loads are done by this production equipment. So, they have rotating machinery which gives you vibratory loads. So, if the live loads are located on top of these floors and beams, so they are to be designed for, you just see this is for 350 to 500 pounds per square inch. So, these are the design load, or sometimes this is called allowable stress. Allowable stress. Normally in shipbuilding you will come across, if you open your Lloyd's register etc., you will find about allowable stress. So, these are actually your allowable stresses for all these structures. Production equipment, then you have drilling equipment. So, these will cause lot of loads, especially your dynamic loading is going to come. So, you can see the static load is only 50 pounds per square inch, whereas your dynamic load is in the order of 350, and if it comes to drilling, then you are in more trouble. It is 1000 pounds per square feet. Sorry, this is square foot, F stands for square feet. So, 1000. Then mud tanks, I do not know why they have give so much of stress on the mud tank. So, this is 1250. Then you have derrick load. Derrick is coming from the cranes. Derrick load is 2500. This is of course kilo pounds. He has given the load, I think the total load. Living quarters, is only 150. This is pound stress level is given. Now, after you have designed this, now the deck truss, the supporting truss for the deck, jacket. So, these are carried down to lower levels. Carry down to lower level means your deck load is ultimately coming to where? I think you are not able to see this, no? So, this is 70%, you take 70% of live load. So, now what is mentioned here is that the weight of this thing, the deck is ultimately you have to come to the deck truss, and then it comes to the jacket, and after the jacket it comes to the pile. So, once you go to the pile, then you have to take 70% of live load. So, your live load, that is these loads when you come to the pile. So, ultimately these loads, I told you, the loads are carried down to the foundation, your pile is the foundation. So, this is the one of the areas. And now, the other point that is to be remembered when you are designing a deck is deck installation. Now, there are actually two methods I have told you. Now, what are these two methods? One is called, number one is called the float-over installation. Now, remember all this, you see the deck design is not easy in your offshore platform for the simple reason is that you cannot in ships actually the deck is quite large. Go visit a oil tanker etc. You will find is on nearly a play field, that is your football 4 or 5 football fields you do, lot of area, but in case of offshore platforms you are very tight on the deck area, because then last class I told you, because then you have to think about the horizontal, how you are going to place the horizontal deck area allocations. If you are unable to do this, you go vertically up, and then you have to connect, because if you increase the deck area, what is you are going to increase the cost of the platform, because that underwater truss, that the size is going to increase. Immediately the size of the underwater truss is going to increase if you increase the deck area. So, you are tight on that, isn't it? So, remember that for offshore platform, cost is a very important factor in design, because of the simple reason that one is the deck area and the other is for deep water. If you go, that means the length of the or the length or depth of the truss is going to increase. As soon as you increase the size of the truss, you are increasing the problems will be increasing. First problem that is increasing in spite of your cost is the wave loading. Immediate increase will be there in the wave loading, and that will give you a sequential increase in the thickness of the members of the truss. So, again you have to completely you have to redesign the whole thing. So, that is a very important consideration, that is you should not go for the unnecessary increase in the deck area, and that is one consideration. Another consideration that most of you will come across is the piping. So, piping, the most intelligent thing to do is cut down on piping or piping reduced to minimum. Can you do this? So, that requires a lot of expertise. Or you try to locate one equipment on top of another by means of what is called gravity feed. You know what is gravity feed? If you see your motorcycle, the fuel tank is located just above the engine. So, that means the engine is getting supply of fuel from a pipe by means of gravity, isn't it? It is just flowing from the tank. So, here if you have this gravity feed, then that also reduces the piping to a large extent. Instead of having two separate your engine and fuel tank at rather two different locations, connect pumps and piping. So, increase in the piping as well as you will require pumps and all that. So, gravity feed, wherever possible you go for that. So, the main purpose is to reduce piping as much as possible. Once you reduce this, automatically you can reduce your deck area. So, deck area, deck area requirement is a major this thing. Now, that is why you will find in most of the platforms you will never see only a single deck, but there are different layers of decks. So, layering of decks is very important, and connecting by your assets or pipings. And some equipments, that means you have to install not in the horizontal mode, but in the vertical mode, say compressors. Compressors can be now whenever you are layering of decks, so that is important, and horizontal or vertical disposition of equipments. Now, these you find out disposition of equipments. So, that means from the you will find that some compressors or say heat exchanger, they can operate vertically instead of horizontal, but if you place them horizontally, you will find that you are requiring a larger amount of deck area, but if you place it vertically, obviously your deck area is less. Now, there are problems will come up when you have a compressor like this. That means you have to have a securing arrangement, isn't it? You just can't have a compressor like located like this. So, it should have some fixing arrangement. So, obviously, instead of one deck you are going to have two decks, or you have number of decks with supports. So, these are some of the arrangements you can think about, because your space requirement is crucial. Okay. Now, most of these equipments are of you have to indent all these equipments. Either this is done by you, or if you are not an expert, that means your offshore contractor will hire, say, a chemical engineer or a mechanical engineer who is going to indent these equipments, and these equipments are all categorized as marine duty. So, these marine duty, say, pumps, compressors, engines, they are ships, the main engine that you are buying or your compressors, etc., they are classed as marine class or marine duty. Now, this marine is, that means the ships will have lot of motions, when it is going in the seaway. Now, the sump of the engine has to be designed in such a way that the engine can take air whenever it is having a rolling, pitching and all these motions. So, in offshore platforms also same thing will come across this. So, here these equipments are to be designed for marine duty. Now, the main thing is you will find this is motion, to take care of motions to be taken care of. So, both for the personnel as for the equipments, this is very important. So, whenever you are designing equipments in offshore platforms, I told you, first thing you try to get the space required, because you are running short of space. First you try to make a layout with the horizontal layout, you are not very satisfied, that means it is going to push up your cost, then you have to design vertically all the decks, layering of the decks, and how to fix the equipments with the associated piping and access plan that is going to come on the top sides. So, topside layout is not very easy, and after you have done all this, then deck has to be installed, isn't it? So, normally what is done, there is the underwater truss that is built separately on the shipyard, that is floated out, or it is carried by your that is the barge, and then it is appended. So, decks are normally positioned on top of the platforms after the underwater truss has been installed and properly secured on the seabed. Now, how are you going to install that deck? So, there are two methods of installation. One is called the floatover installation, and the other one is called the layer. I think that is called the derrick lifting method. Floatover method and derrick lifting method, or rather you write derrick lift method. So, which one you are going to do? Now, if you have a floatover installation, now first, that means your decks or top sides have to be specially designed for this floatover or derrick. The other remember in the when I started my discussion, that means decks are normally designed as two types. One is what? Integrated deck. Have I talked about this? Integrated deck as opposed to another type of deck which is called modular deck, isn't it? So, you see modular deck. Now, next, after you have done this, so these two categories are going to decide on whether you go for a floatover installation or a derrick lift installation. Normally, this modular deck you can go for derrick lift method, but derrick lift method, if you go, this is normally guided by your derrick capacity or crane barge capacity. Crane barge capacity. And in the floatover installation, floatover is normally done by the deck actually being carried by barges. Say barge, actually you have to have a certain mock-up for carrying the barges, and then this is positioned on your jacket columns. So these are your jacket columns. So a barge comes, and this is called the float-over method. Now, float-over method, if you design, that means the column spacing has to be made in such a way that barge entry is possible. Then you design the columns or space the columns in such a fashion that your barge can enter, and then it can deballast and position the deck on the top of the columns. So this is called a float-over method. The other method, of course, is much more simpler. Now there are two types. Float-over also there are two types. One is you can ballast or deballast the barge, and the other is what is called a jack up or jacking up method. Jacking up of deck. Now, this actually the barge ballasting and deballasting is it is more time consuming. Now, in case of inclement weather, where there is rough weather, you do the process very quickly. Normally, the deck is carried on what is called your jacks, screw jacks. You just reduce the jack, and then it comes and sits on top of the columns, and it is done very fast. So this method is faster, jacking up method. So all these things, you go to the offshore site where installation is taking place, then you can have a first hand experience. My class just exposing you to what is there in store. So with this we finish our topsides. That is primarily topsides means topside layout is what I talked about is the GA drawing. Now your next topic that I will discuss after a few minutes will be your mooring systems. This is also very important.